The Stern-Gerlach experiment, a classical interpretation within the unification model of cosmic levels. Abstract. This paper presents an alternative interpretation of the Stern-Gerlach experiment within the framework of the unification model of cosmic levels. This model postulates the equivalence of physical laws, structures, and dynamics across all scales of the universe, from the microcosmic to the macrocosmic domain, linked through scalar unification coefficients. In this context, spin is interpreted as a classical rotational property arising from coupled gravito-magnetic interactions. The observed beam splitting in the Stern-Gerlach experiment is thus explained as the result of classical magnetic orientation and deflection of atoms in an inhomogeneous magnetic field. This approach offers a conceptually intuitive and deterministic perspective that contrasts with standard quantum mechanical interpretations. 1. Introduction. A classical and deterministic explanation for the interpretation of fundamental physical phenomena across different scales remains one of the central challenges in theoretical physics. The unification model of cosmic levels proposes a framework in which all physical elements, forces, structures, and dynamical processes are fundamentally equivalent across the microcosmic and macrocosmic domains. According to this model, physical systems at different scales are related through scalar coefficients that establish proportional and dimensional correspondences. One of the simplest of these coefficients is the linear unification coefficient, defined as Cu equals 2 pi times 10 power 22. Within this framework, it is assumed that any significant material particle or nucleus generates two antagonistic force fields in its surrounding region, referred to as gravito-magnetic forces. These fields induce torsional and rotational motion along the complete structure, giving rise to a preferential magnetic polarity characterized by a north-south (NS) orientation. This mechanism provides a classical basis for the concept of spin, which is here interpreted as a universal property of structured matter, manifesting consistently across all scales, from elementary particles and atoms to stars and planets. The aim of this work is to reinterpret the Stern-Gerlach experiment within this theoretical framework, offering its observed results. 2. Theoretical framework. The unification model of cosmic levels is based on the hypothesis that the same structural and dynamical principles govern all levels of physical reality. In particular, it assumes 1. Scale equivalence, physical laws and interactions are invariant across cosmic scales. 2. Dimensional correspondence, systems at different scales are related through unification coefficients such as Cu. 3. Gravito-magnetic coupling. All significant material nuclei generate paired antagonistic fields that induce rotation and polarity. 4. Universal spin. Spin is not an exclusively quantum property but a classical rotational manifestation arising from these coupled fields. Under this framework, magnetic polarity and rotational dynamics are intrinsic features of matter and are not restricted to quantum descriptions. 3. The Stern-Gerlach experiment. The Stern-Gerlach experiment consists of a beam of neutral silver atoms produced by thermal evaporation and collimated into a narrow stream. This beam passes through an inhomogeneous magnetic field generated between the poles of a magnet and is subsequently detected on a screen. In conventional quantum mechanics, the splitting of the beam into discrete components is interpreted as evidence of quantized spin states. However, within the unification model, the phenomenon is interpreted differently. As the atoms traverse the magnetic field, they become oriented according to their intrinsic polar structure. Each atom aligns along a north-south axis due to the interaction between its internal gravito-magnetic fields and the external magnetic field gradient. Depending on their orientation and position within the field, the atoms experience forces that deflect their trajectories toward one or the other magnetic pole. Thus, the observed splitting of the beam is attributed to classical magnetic interactions and orientation effects, rather than to inherently quantized states. 4. Classical analogy and interpretation. A useful analogy can be found in the behavior of iron filings in the presence of a magnetic field. When placed near a magnet, the filings become magnetized and align along the magnetic field lines, showing a clear tendency to concentrate near the poles. Similarly, in the Stern-Gerlach experiment, the silver atoms can be understood as acquiring a temporary magnetic orientation when subjected to the external field, leading to their direction and spatial separation. Additionally, iron filings often form well-defined concentric patterns that visually represent magnetic field lines. Within the unification model, such patterns may be interpreted as reflecting orbital-like structures associated with aligned atomic configurations, providing further support for a classical, geometrical interpretation of magnetic interactions. 5. Discussion. The interpretation presented here challenges the conventional quantum mechanical explanation of the Stern-Gerlach experiment by proposing a classical, scale-invariant mechanism based on gravito-magnetic interactions and universal spin. While this approach offers conceptual simplicity and intuitive appeal, it departs significantly from established quantum theory. Therefore, its validity depends on its ability to provide consistent explanations not only for the Stern-Gerlach experiment but also for other phenomena traditionally described by quantum mechanics. Further theoretical development and experimental analysis would be required to assess the predictive power and internal consistency of the unification model. 6. Conclusions. Within the framework of the unification model of cosmic levels, the Stern-Gerlach experiment can be interpreted as a manifestation of classical magnetic orientation and deflection of atoms in an inhomogeneous magnetic field. This interpretation is based on the assumption of universal gravito-magnetic interactions and the equivalence of physical laws across all scales. Spin is thus understood as a classical rotational property rather than an intrinsically quantum phenomenon. Although this perspective contrasts with standard quantum mechanics, it provides an alternative viewpoint that may contribute to broader discussions on the unification of physical theories. Acknowledgements. The author acknowledges the conceptual development of the unification model of cosmic levels over several decades of independent research.